Okay, so today we are looking at successive derivatives. Successive derivatives. So with successive derivatives, we are basically, if we are given a function, we differentiate it as many times as we can. So the main application of successive derivative is when you're going to look at the nth derivative, we are trying to formulate mathematical expressions that we can use to find the nth derivative for different types of functions. So before we derive those formulas, we need to look at the notation that we're going to use in this video. So if you have y is equals to f of x, if you're given a function y is equal to f of x, the first derivative of this function is equals to f prime x, or this can be also dy dx, isn't it? And same thing, the second derivative can be f double prime x, which is equals to dx squared. So this is the basic notation that we know for when you're differentiating. So, but in this video, we're going to use these two notation, whereby which means you can also find the third derivative if you are continuing to differentiate for this function. This is the third derivative. And if you continue to differentiate, you can go down to find the nth derivative of the function, which is equals to f of n x, which is equals to dn, is equals to dn y dx n. So this is the notation that you're going to use for the nth derivative. So obviously there are different types of functions. We have the logarithmic function, exponential function, polynomials, and trigonometric functions. So we need to know how to differentiate to find the nth derivatives of all of those functions. So we are going to start with the exponential function. We're going to start with the exponential function. Exponential function. So the general form is we are given y is equals to e ax. So we are given this function. So the first derivative of this function is going to be ax. We are differentiating the power, then multiplying the entire function with the derivative of the power. So the second derivative is the same thing. We're going to have a times ax, which is equals to a squared ax, and the third derivative is going to be a times a squared ax, which is equals to a cubed e to the power ax, right? So if we continue to differentiate this, the nth derivative, so if when you come back to look at this one, so the first derivative, the power of a is 1. The second derivative, the power of a is 2. The third derivative, the power of a is 3. Then the nth derivative, which means the power of a is going to be n. So n is equals to eax. So this is how you can find the nth derivative if you're given an exponential function of this form. So this is very important. This is one of the formulas that you are going to use. And another thing, we are going to look at the polynomial function finding the nth derivative of a polynomial function. So with the polynomial function, you are given that y is equals to ax plus b to the power n. We're given that y is equals to ax plus b to the power n. So with this one, or let me just say to the power m here, since we'll be using the n derivative. So the first derivative of this polynomial is going to be m ax plus b, right? Going to be m ax plus b, m minus 1, isn't it? And then if you find the second derivative, it's going to be m minus 1 ax, or here we also find the first derivative of what we are using the chain rule. We find the first derivative of what is inside the bracket, which is a. So the second derivative here is going to be m, then we take the power, we multiply with the power, then this is ax plus b, m minus 2, since we minus 1 from the power, times, and here there's this a, right? And then times the first derivative of what is inside here, which is a again. So y2 will simplify to a squared, this a and this a squared, m minus 1 ax plus b, m minus 2. And then if you find the third derivative for this one, you do the same thing. Take down the power, you have a squared m minus 1, and then you're going to have m minus 2 ax plus b, and then m minus 3 times the first derivative of what is inside, which is a. And then if you simplify this, you're going to get a times a squared is a cubed, m minus 1, m minus 2, we have ax plus b, m minus 3. So now let's look at the pattern. So we started with the first derivative, y1, so the power of a was 1 here, y2, the power of a, y2, the power of a is 2, and y3, the power of a is 3, which means if you find the nth derivative for this one, the power of a is going to be n. That's the start. And then we come back to this expression. We are looking for the first derivative, the power of, we had m minus 1. And for the second derivative, we have m minus 2. For the third derivative, we have m minus 3, which means for the nth derivative, we are going to have what? We are going to have ax plus b, m minus n, isn't it? And then now we are looking at, this term. When this first derivative, we have m, second derivative, we have m minus 1, third derivative, we have m minus 1, m minus 2. So now, which means when it's third derivative, we have m minus 2 here for the third derivative. Second derivative, we have m minus 1. First derivative, we just have m. So which means if we are looking at this pattern, we are going to have m minus 1, m minus 2, and this will go to m minus, when you're looking at this is 3, right? Which means here we have 2, which means this 2 is equals to 3 minus 1, right? And here you have 2, here you have 1, here you have 1. And this 1 is equals to 2 minus 1. So this is going to be n minus 1. This is going to be n minus 1, right? So this is going to be m minus 1, m minus 2, and this will go to m minus n plus 1, right? And then if you subtract 1 here again, because here we started with m, we subtracted 1, we got m minus 1, we subtracted another 1, we got m minus 2. If we subtract 1 here, we're going to get m minus n, isn't it? And this, if we continue to subtract 1, you're going to get 2, 1 here. So, but then now, with this expression, we can divide by these terms, whereby we are going to have m minus n, we are going to have m minus n minus 1 going to 1. So this will be, the numerator is the same thing as m factorial, the denominator is the same thing as m minus n factorial. Because if you are given, remember, if you have 4 factorial, this is the same thing as saying 4, starting with 4, right? And then 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, right? So this is 4 factorial, is the same thing as 4 times 2 times 4 times 3 times 2 times 1. So the same thing here. We start with m, we minus 1, we minus 2, up until we get to 1, isn't it? So this is going to be m minus m factorial. And then here we start with m minus n, right? And then from m minus n, we minus 1. And then we continue up until we get to 1, which is going to be m minus 1 factorial. So coming back to this, to our polynomial, so this part can be reduced to m factorial over m minus n factorial. So now, if we are given y is equals to ax plus b to the power m, you can find the nth derivative of this one to be equals to what? To be equals to an times m factorial over m minus n factorial times ax plus b m minus n, where a and b are constants. And for this one, this expression works. This expression will work when this expression is applicable when m is greater than n. So this is applicable when m is greater than n. So what about when m is equals to n? So we are still looking at the polynomial. So when m is equals to n, okay, let me rewrite the nth derivative. We have an times m minus n factorial times ax plus b m minus n factorial. So now we are saying when m is equals to n, so here we are going to have yn is equals to an times n factorial over n minus n factorial. So where there is m, we substitute with n. So we're going to have ax plus b n minus n. So this will simplify to yn, this will simplify to an times n minus n is what? It's 0. And 0 factorial is 1. So this is going to be an. And then here we're going to have n minus n is what? It's 0. Anything to the power 0 is what? It's 1. So this one will simplify to this. It will simplify to this. When m is equals to n, we're going to get yn is equals to an times n factorial. So this is very important. What about when m is less than n? So if you are given y, you still have ax plus b to the power m, but now m is less than n. So a typical example of this, if you have y is equals to a squared, and then I'm saying find the fifth derivative. find the fifth derivative. So with this one, our m is what? Our m is 2, as we can see. But if I'm saying find the nth derivative, our n is equals to what? 5, right? So you can see here that m is less than 5. So our first derivative here is going to be what? Is going to be 2x. Our second derivative is going to be 2. Third derivative is going to be 0. Fourth derivative is still 0. Fifth derivative is still 0. So you can see here, if m is less than n, we are always going to get what? Your nth derivative is going to be 0. So from this case, when m is less than n, your nth derivative is equals to 0. And then now we need to look at another condition when m is equals to -1. When m is equals to -1, when the power is negative. So we've looked when the power is greater than n, and also when the power is equals to n, and when the power is less than n. Now we are looking when the power is -1. So we can rewrite y is equals to ax plus b to the power -1. So we want to find the nth derivative here. So we need the expressions of the nth derivative. So we're going to have y1 is equals to what? Is equals to -1 ax plus b. We are going to -1 here because we're using the power rule. And then we multiply. We find the derivative of what is inside, which is going to be a, which means this is going to simplify to -1 ax plus b minus 2a. And then we differentiate again. If we differentiate again, we're going to have -1, -2 ax plus b minus 3 times a times, when you differentiate what is inside again, you're going to have another a, isn't it? And then this will give you this will give you a squared, right? So from this point, simplify this by this -2 is the same thing as -1 times 2, right? So we are going to split this. We're going to split these to -1, 1 times 2 ax plus b minus 3 times a squared. So here I factored out -1. I got this -1, right? This is this -1. And then I have 1 times 2. I have 1 times 2. So -1 times -1, you're going to get y. So it's going to get -1 squared times 1 times 2 ax plus b minus 3 times a squared. And then if I find the third derivative again, I'm going to have -1 squared, and then I'm going to take the power -3. It's going to be -3. We have 1 times 2 ax plus b, and then the power is going to be -4 times a squared times the first derivative of what is inside is going to be a again, and then that will lead us to a cubed, right? A to the power 3. So, and again here we have to simplify this. From here we're going to factor out -1 here. So we're going to have -1 squared times -1, and then we are going to have 1 times 2 times the 3, and this is going to be ax plus b minus 4a cubed. And then here this y3 is going to be -1 to the power 1 is going to be what? -1 cubed, because we get the power same base. So we're going to have 1, 2, 3 ax plus b minus 4a cubed. So now if you differentiate this, you want to find the yn, the n derivative, you're going to have -1. And then when you're looking at this one, let's start from here. So we have 1 y1, the power of a is 1, and the power of -1 is 1. And then y2, the power of -1 is 2, the power of a is what? Is 2. And then y3, the power of -1 is 3, the power of a is 3, which means here is going to be n, right? And then also we are going to have, when you're looking at this, you have y1, which means here it's 1 times 1. We have y2, we have 1 times 2. We have y3, we have 1 times 2 times 3, which means for n, we are going to have what? We are going to have 1 times 2 times 3 times 4 up until n, right? So this is up until n. So this is going to be what? This is the same thing as n factorial. And then coming back to this, you have, if for y1 you have -2, for y2 you have -3, for y3 you have -4, which means this -4 is the same as -3 plus 1. This 2 here, this -3 here is the same thing as, this -3 is the same thing as -2 plus 1, right? So here we have -4, which is 3 plus 1, which means if we come back here, ax plus b is going to be -3 plus 1. This 3 was the third derivative. Here is 2 plus 1. This 2 was the second derivative. For the nth derivative is going to be what? It's going to be n plus 1. And then we are coming back to the power of a, 3, which means for a is going to be a n, isn't it, for the nth derivative? So we can rewrite this. We can rewrite this as yn is equals to -1 n a n all over ax plus b to the power n plus 1. So when m is equals to -1, this is how you can get the nth derivative. So now let me group everything. So if you're given a polynomial, y, y is equals to ax plus b to the power m, the nth derivative will be m factorial over m minus n factorial a to the power n ax plus b m minus n, and this, we know that this is m is greater than n, and then also we are going to have a n factorial, and then this is when m is equals to n, right? And then it's 0 when the nth derivative of this is 0, when m, which is the power, is less than the nth derivative, and it's also -1 to the power n a n factorial over ax plus b n plus 1 when m is equals to -1. So this is how you find the nth derivative of a polynomial. Finding the nth derivative of a polynomial function while considering the conditions of the power with respect to the certain derivative. So when you look when the power is greater than n, the nth derivative, this is the formula that you use. When it's equals to n, this is what you use. When the power is less than n, it always goes to 0. And then when the power is -1, this is the expression that you use. So we are going to see the applications of this. And then now we want to also find the nth derivative of a logarithmic function. So we are looking at the log function. So if you have y is equals to ln ax plus b, we are given the general form of the logarithmic function. So y1, which is the first derivative, is going to be what? The first derivative of what is inside, which is a, over the function inside is going to be a plus b, right? And then we can rewrite this as ax plus b to the power -1, right? If you bring the denominator to the numerator, so the power is going to be -1. So y, the second derivative, y2, is going to be what? It's going to be a -1. We bring -1 down, ax plus b, and then we -1 is going to be -2, and then we find the derivative of what is inside the bracket using the chain rule, so it's going to be a, right? Which y2 simplifies to a squared -1 ax plus b -2, isn't it? And then again you find y3, which is the third derivative, is going to be a squared -1, and then bring down the power, is going to be -2 ax plus b -3, and then again you find the first derivative of what is inside, which is going to be a in our case. You can simplify this to a squared times a is what? It's a cubed, isn't it? And then from -2 here, we are going to factor out -1, such that we're going to have -1, we are left with 1 times 2. This is ax plus b -3, right? And then -1 is going to be what? This is a cubed, this is -1 squared, 1 times 2 ax plus b -3. So this is our third derivative. So from this one, I want us to look at the pattern again. So for the first derivative y1, you have 1 here, the power of a is 1. y2, you have the power of a is what? It's 2. This is 2. y3, the power of a is 3. This is 3, right? But then y1, the power of -1 is like 0 here, and then y2, the power of -1 is like 1. The power, when you look at y3, the power of -1 here is 2, right? So what does this mean? If we are looking at yn, this is going to be what? Let's start with a 3, 2, 2, which means it's going to be, if it's n here, it's going to be an, right? But then now the power of -1 is 1 less than the power of, it's 1 less than the derivative. So if it's y3, it's going to be 2 here. If it's y2, it's going to be 1 here, which means -1 is going to be what? n minus 1. And then also looking at this, when it's 2 here, you have 1 here. When it's 3 here, you have what? You have 1, 2, isn't it? Which means when it's n, you're going to have what? You're going to have n minus 1. Why? N minus 1 factorial, because this is 3, this is 2, right? And 2 is equals to 3 minus 1. And when you go to the nth derivative, it's going to be what? When you are going to the nth derivative, we are going to have n minus 1, isn't it? in order for us to get the value of the value in this position. So we are going to have n minus 1 factorial and then ax plus b. Ax plus b, this is 3, which is minus n, isn't it? So this will simplify to an minus 1, n minus 1, n minus 1 factorial all over ax plus b to the power n. So this is the general formula that you can use to find the nth derivative of y is equals to ln ax plus b. This is for logarithmic functions. And then now we also want to see how we can find the nth derivative for trigonometric functions. For trig functions, the derivation is also relatively simple. If you're given y is equals to sine ax plus b, right? And then from here, we're going to find y1 is going to be what? Y1 is going to be a cos ax plus b, right? Differentiating sine, you get cos. Differentiating the function inside, you're going to get a, isn't it? But then now remember, when you're differentiating trigonometric functions, they oscillate. Sine, cos, sine, cos, sine, cos. But here we are looking at specifically at x. Oh, sorry, we're looking at specifically at sine. So how can you maintain sine? So you're going to use this identity cos theta is equals to sine theta plus pi over 2. This is just a way of saying that these functions are out of phase by pi over 2. They're out of phase by 90. Because if you're looking at the function of sine and cos, this is the function of sine, y is equals to sine x, and then the function of cos is what? It's like this, and then this is y is equals to cos of x. So these two, this is the same function. It's just that this one is out of phase by pi over 2, so by 90. So now we are from this expression, we are going to, this is our theta, right? So I'm going to rewrite this as y1 is equals to a sine. Now this is my theta, so this is going to be theta sine theta, which is ax plus b plus pi over 2. I rewrote this using this identity. Instead of cos, I wrote sine, right? So that's how you go about solving this one. And then this is going to be, so our y1 is equals to a sine ax plus b plus pi over 2. This is our y1. And then y2, we differentiate this. If we differentiate this, we're going to get a cos ax plus b plus pi over 2. Differentiate what is inside, you're going to get a, right? Which means y2 is equals to a squared cos ax plus b plus pi over 2, right? And then if you're looking at this one again, you can see we have cos, but we don't want cos, we want sine, because initially we were working with sine. So we use the same identity, which means now this is going to be theta, because remember cos theta is equals to sine theta plus pi over 2. So now we are going to get y2 is equals to a squared sine. So my theta here is going to be ax plus b plus pi over 2 plus this pi over 2, isn't it? So this was theta. This was theta, then I added another pi. So now allow me to write this as y squared is equals to a squared sine ax plus b. This and this is the same as 2 times pi over 2, isn't it? And then if we are finding the third derivative of this, we are going to have a squared cos, because the derivative of sine is cos ax plus b plus 2 times pi over 2. And then we're differentiating what is inside, we're going to get a again. So y3 is equals to a cubed cos ax plus b plus 2 pi over 2, right? And then we have cos again. How do you remove cos? We use the same identity. And then this is going to be my theta now. This is going to be my theta. So y3 is equals to a cubed sine ax plus b plus 2 pi over 2 plus pi over 2 again. So now we are here. So, and then we can simplify this to y3 is equals to a cubed sine ax plus b plus, if you combine this, you're going to get what? 3 times pi over 2, isn't it? So now I want us to see the pattern. So for yn, the nth derivative, so if it's going back, if it's the first derivative, the power of a is 1, and here you have 1. For the second derivative, the power of a is what? Is 2, and here we have 2. For the third derivative, the power of a is 3, and here you have 3. So for the nth derivative, we are going to have an sine ax plus b plus n pi over 2. So this is the nth derivative. If you're given a trigonometric function like y is equals to sine ax plus b. So this is the same thing for cos. If you're given y is equals to cos ax plus b, if you're given this, the nth derivative of cos is still going to be yn is equals to an cos ax plus b plus n pi over 2. Still you are using the same condition, using the same, because this is going to be sine theta is equals to minus cos theta plus pi over 2. So if you are using that one, you're still going to get what? You're still going to get the nth derivative of cos ax plus b is going to be yn is equals to a to the power n cos ax plus b plus n pi over 2. So now we have done trigonometric exponential polynomial. So we are also interested in looking at the combination of the function. When we have combined them, what is the nth derivative when you have combined the function? So the basic one, we are going to look when y is equals to ax sine bx plus c. So if I given a function like this one, and then we want to find the nth derivative of this function, we're interested in finding the nth derivative of this function. So one thing that we have to one thing that we have to focus on with this one, let's start with the first derivative. Okay, if you're starting with the first derivative, we're going to have y1, right? Y1 is equals to, this is u, this is v. We are going to use the product rule. So we are going to have, starting with u, going to have a e ax, right? A e ax. We're going to have y is equals to a e ax sine bx plus c plus e ax. When you differentiate sine, you're going to get cos bx plus c times the first derivative of what is inside is going to be what? Is going to be b, isn't it? So this y is equals to, if you want to simplify this, going to factor out the like terms, right? So you're going to have e ax is going to be what? A sine, it's going to be a sine bx plus c plus cos bx plus, is going to be cos bx plus c, and then of course this is multiplied by b, which is this b, right? So now at this point we want to simplify this. We have a, we have b. So this, we want to simplify this. How can you simplify this? We're going to apply the compound angle formula. We're going to apply the compound angle identity, whereby we are saying sine a plus b, sine a plus b is equals to sine a, is equals to sine a cos b plus sine b cos a, right? So now we want to rewrite this function into this form. So how are you going to do that? Using this, the product, using the compound identity of sine. We are going to say let a, we are going to let a to be equals to, let a to be equals to cos alpha and b to be equals to r sine alpha again. So if you rewrite that, y is equals to e ax a sine bx plus c, instead of a, now we are going to have r, instead of a we're going to have r cos alpha times sine bx plus c plus, instead of b we're going to have r sine alpha times cos bx plus c. So now from here we can factor out r. Remember, this is y1 because we found the first derivative. We're just simplifying y1. So y1 is equals to r, we factored out r e ax, right? Now we are left with what? With cos alpha sine bxc plus sine alpha cos bx plus c, isn't it? So this is somehow similar as cos a sine b plus sine A cos B, right? Which means our A is what? It's alpha. Our A is alpha, our B is this one. So we can combine these to sin A plus B. So we are going to rewrite this in that format. So this is going to be y1 is equals to R E AX sine. Our A is what? It's alpha plus hopefully it didn't erase the contents. Where were we? Oh, we're here. So we say our A here it's alpha, and then our B is going to be plus. Our B is going to be plus bx plus c. So now our y, we've reduced y1 into this form, right? So from here we can also find y2. So still we're using the product rule. Y2 is going to be what? Y2 is going to be R A E AX sine alpha plus bx plus c plus R E AX times cos alpha plus bx plus c times the first derivative of what is inside is b. So here you're going to have y2 is equals to, if you simplify this, factor out again like times, which is also r, we're going to have R E AX A sine alpha plus bx plus c plus b cos alpha plus bx plus c. Right, this is the second derivative. And again here we know that A is what? A is equals to this, B is equals to this. So we substitute again. Y2 is equals to REAX. It's going to be R cos alpha sine alpha plus bx plus c plus, this is going to be R sine alpha cos alpha plus bx plus c, isn't it? And again, using the compound angle, this is going to be A, this is going to be B, right? Using the compound angle, you're going to get the compound identity, so not the compound angle. The compound identity is going to be y2 is equals to REAX. This is going to factor out what? When you factor out R and multiply with this R is going to be R squared, right? And then you're going to be left, if you use the compound identity, you're going to have sine A, which is alpha plus B, this is our B, is going to be what? It's going to be alpha plus bx plus c, isn't it? And then, which means y2 is equals to R squared EAX sine alpha plus alpha is 2 alpha, so we're going to have bx plus c plus 2 alpha. So from here we can see that if you continue, you want to find yn is going to be what? If it's y1, the power of r is 1, right? And the coefficient of alpha is 1. If it's the second derivative, the power of r is what? Is 2, and the coefficient of alpha is 2, right? So this we're going to have RNEAX sine bx plus c plus n alpha. But remember, we used alpha and r were not initially part of the were not constant that were part of the equation. So we need to represent r and alpha using a and b. How do you do that? So here we need to substitute. Instead of r and alpha, we need to substitute in terms of a and b, because those are the constant that we know, those are the constant that we're given from the beginning of the equation. So now we know that we know that a is equals to r cos alpha, right? And then b is equals to r sine alpha, right? Which means a squared plus b squared is going to be equals to what? R cos alpha squared plus r sine alpha squared, which is a squared plus b squared is equals to what? R squared cos squared alpha plus r squared sine squared alpha, right? So this is going to be a squared plus b squared is equals to, factor out these, you're going to r squared, you're going to have cos squared alpha plus sine squared alpha, and then you know the identity, cos squared plus sine squared is what? It's 1. So we have a squared plus b squared is equals to r squared, which means now we can represent r in terms of a and b. So r is equals to root a squared plus b squared. And then now we need to represent alpha in terms of a and b. So coming back to these initial equations, we can say b over a is equals to what? B is equals to r sine alpha over a is equals to r cos alpha, and then alpha is going to divide, and then we know that sine alpha over cos alpha will be what? Will be tan alpha, and then we can say alpha is equals to tan inverse of b over a, right? So now from this nth derivative, where there is r, we substitute this, where there is alpha, we substitute this. So we can write it as yn is equals to root a squared plus b squared to the power n, where there is r here, and then eax sine bx plus c plus n, and then where there is alpha, we substitute tan inverse of b over a. So now this is the general formula. This is the general formula of finding the nth derivative of y is equals to eax sine bx plus c. So these are the main functions that we normally use to find the nth derivative. So we've talked about the polynomial, logarithmic, exponential, trigonometric, and then we also look at the combination of a exponential and trigonometric. So finding the nth derivative, we are going to get this. So this is the end of the video.